Automating job applications on LinkedIn. Think about how much time you spend applying to jobs on LinkedIn. Now, imagine automating that entire process. We're going to show you how to make your job search effortless and efficient. Now, without any delay, let's look at the final working result of our project. As you can see, it auto-logs into the LinkedIn homepage, goes to the job search page, searches with a keyword, and applies the filters. Once the filtered search results appear, it starts applying for the jobs. Once the page is loaded, it will answer the questions as you see here. We will look into more details on how we are answering the questions in the next part of the video. Once everything is done, it reviews and submits your application, and then goes to the next company to repeat the same process. But at this point, you can see how quick the job application process is. Remember, it's still up to you to put the right search criteria in place. Overview of our project. To automate the job application process on LinkedIn, we utilized Playwright, which is a Node.js library, along with a simple AI model to dynamically answer job-specific questions. If you're not familiar with Playwright, it is essentially a Node.js library for automating browsers. Login and navigation. The script begins by automatically logging into LinkedIn using the provided credentials. Once successful, it navigates directly to the job search page. Job search and filtering. At this stage, the user is prompted to input their search criteria, which can include job titles, specific skills, or company names. For instance, you might enter data scientist. Once the search criteria are set, the script automatically applies relevant filters to streamline the job search. By default, we apply the Easy Apply filter, which focuses on jobs that can be applied to quickly. With the search results loaded, the script detects all job listings on the current page. It then checks the status of each job to see if the user has already applied. If a job has not been applied to, the script initiates the application process and begins filling out the necessary fields with pre-saved user data. We use an NLP model, TF-IDF, to answer job-specific questions dynamically during the application process. We'll look into the details of how we answer these questions in the next part of the video. Review and submission. After answering all the questions, the script reviews the completed application and submits it. It then moves to the next job listing. This process repeats for all job listings on the current page. Let's go through the methodology explaining the step-by-step process. Let's have a look at flow diagram. The script initiates the process by applying the filter and identifying job listings with Easy Apply, then clicks on it to start the application. This is where you'll see a window to fill in your static details like email and phone number. After that, you will answer additional questions. The questions can be classified into 3 types. Numeric questions. Example: how many years of experience do you have in? Drop-down questions requiring you to select an option from a list. Binary questions expecting a yes or no response. For numeric questions, the script first checks if an answer to this specific or a similar question, prioritizing the key skill mention, is already stored. If the answer is available, it fetches the response from the JSON file. If not, it requests the user to provide the input through the terminal. For drop-down questions, the script fetches the result if the exact question is present in the file. If not, you can select a response directly through the user interface. For binary questions, it follows the same approach, fetching the response if the exact question is stored, or prompting you to respond through the UI for a new question. In these cases, we are not using any models because drop-down and binary questions are minimal and usually repetitive. However, this approach might benefit from an auto-detection system in some instances. The model answers numeric, drop-down, and binary questions by checking existing responses in local files. It prompts the user for new answers if necessary and stores them for future use, continuously learning and improving. Once all questions are answered, the script checks for the next button. If it is present, it means there are more questions to answer in the next tab, so the process repeats until you reach the review stage and submit the application. After completing one job application, the script moves on to the next job and starts the process again from filling in the static data. Basic setup. Let's go through the basic installation of the setup. Make sure you have Node.js installed in your system type Node.v. and also make note of the node package manager by typing npmv. So once you have cloned the repo, you will be seeing the package.json. Make sure you have Playwright dependency, npm install Playwright, and browser extension for Playwright npx Playwright install. And also we will be using natural module, so install it npx install natural. Let's look at how the script works. This is our main file send application.js, and you see the helper functions utils binary, utils dropdown, utils numeric. These functions handle the binary dropdown and numeric questions respectively. Here are JSON files for each type of question where we store the responses. Numeric responses.json. Initially, all these .json files were empty. As you start filling in new responses, they store the answered values, which are used later when a similar question is asked. Dropdown responses.json. Notice that the email we are including is also a drop-down response. And binary responses containing yes or no, and this is our sample resume. Now, let's discuss the flow of the main function. First, when we start by logging into LinkedIn, script launches a Chromium window by default. In case you want to change it into Chrome, uncomment this lines and comment out Chromium line. And make sure you input your test email and password in respective fields. And this wait for selector is responsible for ensuring the script waits until you reach the LinkedIn homepage as we set timeout to 0. And once login was successful, directs to the job search page. Here you can give the input through terminal or directly within the code. And then script applies easy apply filter by default. And you can see we have added relevant timeout to load the page completely before it starts applying to the jobs. Now we initializes two variables, current page to keep track of which page it is in, and job counter to count the number of jobs applied. Navigating to the current page, while loop is set true, continuously applies the job listed until no more pages are available. It logs the current page number and number of jobs on the page. If no jobs are found, it exits the loop. Now processing each job, it increments the job counter, logs the job as being processed, and clicks on the job, which enables you to see it on the right side of the page. Now for each job listing there can be 3 cases. Case 1. You have already applied to the job. If print skipping and continue moving to next job in the list. Case 2. Not an easy apply jobs, to handle the case with external links, but we don't encounter any such case because we apply the filter easy apply by default. The script then checks for the easy apply button. If the button is found, it clicks on it. If not, it logs a message and skips to the next job. If it didn't encounter any of the above situation, it start applying to the job. So first it fills the static details email address. It can be with the possible labels of email address or email. And then it attempts to select the phone country code from a drop-down menu. And fill the phone number. Let go the function. So this is the assist function. It check the labels. It can be with the name of mobile phone number or phone. Once we filled the static data, we move to handle next or review function, which recursively answers questions until it reaches the review stage. Let's have a look at it. The function starts by defining a Boolean variable has next button set to true, indicating that the process should continue looking for next buttons if the button is present. Clicks on it and calls answer questions function, and if the button is not found, has next button is set to false, exiting the loop. So if no more next button are there, it's time to review. It searches for it and clicks on it, and log the message and clicks on the submit. Once you submit, there will be a pop-up, so we are attempting to dismiss on it, so it find the another job in the job listing. And looking at answer question function, which contains these helper functions to handle each question type. Here you see we are importing this answer dropdown and an answer binary from these respective util files here. Let's have a look at numeric handler briefly. This function is responsible for handling numeric questions on the LinkedIn job application form, finds all the labels with input numeric filed. And we loop through the questions, and for each question, it tries to find the most similar question from the database. And only retrieves the answer if it's greater than the threshold value, which we say here to 0.7, or consider it as a new question. And if we go to function, which handles this, handle new question, ask the user to provide with an input, and save the answer to the numeric response.json file. And this is one more important function to calculate the similarity. We have imported these components from Natural for text processing. We use TF-IDF to calculate the cosine similarity between two questions. And we use this function to get most similar question prioritizing questions containing keywords we defined, where we are providing weight those sentences with keywords that are defined above. And coming to the utils binary function identifies all the binary questions using the CSS selector and process each one, checks if the question has been answered before. If not, it calls handle new question binary to handle and store new questions, and it is responsible for click yes element or no element. So the way it handling the question is continuously checks for a user selection, yes or no, every second, and return the responses. And here we are storing the response in a file. In similar fashion, it answer drop down as well. Checks if the answer is already present. If not, it waits for the user to select an answer via the browser UI and stores the answer. So that's how we are handling these questions with their common CSS selector. If a window contains a numeric-based question, it checks for next type of question, which is binary, and gradually answers all the questions in the window. And repeat this process of answering question unless the page doesn't have any next button, and submits the application. And once you finish all the job listing in the current page and click on the next page button until there are no more pages existing. Let's run the code. unlocking the future and upcoming developments in our project. As the next phase, one can think of expanding its automation capabilities. Here are a few important points. We can use advanced models to increase the accuracy of identifying similar questions. Also, extend the use of these models to answering drop-down and binary questions as well. Secondly, if you have observed, there is another kind of question format that we are not handling, which is a text-based input, expecting any alphanumeric values. However, it doesn't lead to any errors because we have provided a wait until every question is answered, but feel free to try it out. And finally, as we advance, we plan to develop methods to combat LinkedIn's auto-detection systems and also integrate with serverless functions, such as AWS Lambda, to trigger and manage job applications. So instead of applying for multiple jobs in quick succession, we can space out your applications randomly over several hours or days. And we can also try to introduce random delays to mimic the human behavior. Such strategies can help mitigate auto-detection systems. By implementing such methods, we aim to create a more robust and reliable automation tool for LinkedIn job applications. Thank you for watching the video. Stay tuned for these exciting updates and more such videos.